Hello guys, welcome to this class. Please make sure you subscribe to this channel, turn on the notification button so that you'll be notified whenever I post a new video. Now in this series, we're going to be looking at the alkanes. Now, the alkanes are the simplest organic compound made up of carbon and hydrogen only. They are made up of only carbon and hydrogen. Hence, they are called hydrocarbons. The alkanes are called the hydrocarbons. Now, what kind of hydrocarbons are they? We said we have two types of hydrocarbons. We have the saturated and the unsaturated. The alkanes are called the saturated hydrocarbons. They are saturated. Why are they saturated? They contain only single bonds. Only single bonds. If you look at the alkanes, they contain single bonds only. For instance, when you look at this compound like this is an alkane. All the bonds present in this compound are what? Single. There is no double bond anywhere. Are we getting it now? So a compound that contains only single bond is said to be what? Saturated. And alkane is one of them. The alkanes, they have the general formula CnH2n plus 2. This is 2n, not n. It's 2n plus 2, where n is equal to 1. N can be 1, it can be 2, it can be 3. Now, in the next slide, we are going to look at the n is equals to 1, the name of the compound that is formed. N is equals to 2, the name of the compound that is formed, and n is equal to 3, the name of the compound that is formed. Now, having known that the alkanes are called paraffin, they are called paraffin because they lack affinity. They lack affinity. Hence, they are called paraffin. They do not easily react with other compound. Now, the reason why the alkanes do not easily react is because they lack a pi bond. The alkanes lack a pi bond. That is to say, they lack a double bond. Hence, there is no site of reactivity. Lack pi bond or pi electrons. Hence, there is no site of what? Reactivity. Now, let's look at the names of the first 10 alkanes and their chemical formula. The names of the first 10 alkanes and their chemical formula. Now, if the number of carbon N is equal to 1, the name is what? Is methane. Is methane. Now, from the general formula, we said we have what? Cn. Let me write the general formula here. CnH2n plus 2. So when our n is equals to 1, it will be C1H2 times 1 plus 2, and that will give us C1 will give us C. H 2 times 1 is 2 plus 2 is how many? 4. So this is what? CH4, and the name is methane. So you have CH4, the name is methane. Now when n is equal to 2, the name is what? Ethane, and then it becomes C2H2 times 2. Wherever you see n in this formula, put 2 plus what? 2, and this will be equals to C2. 2 times 2 is 4 plus 2 is how many? 6. C2H6. Then when n is equals to 3, this is what? Propane. Okay, it continues like that. Now this one, if you follow the same approach, is going to give us C3H8. When n is equals to 4, the name is butane. So this gives us C4H10, and when n is equals to 5, this is pentane, and the formula is C5H12. Then when n is equals to 6, you call it hexane. The formula is C6H14. When n is equals to 7, you call it heptane, and then the formula is C7H is 67H16. Then when N is equals to 8 is octane, and that is C8H18. When N is equals to 9, you call it nonane, and the formula is C9H20. And finally, when N is equals to 10, the name is decane, and the formula is what? C10H22. Now each of these formula corresponds to this general formula of what? Of Cn, corresponds to the general formula of CnH2n plus 2. Now notice a general structural pattern between the members of the alkane in such a way that the first differs from the, or the second differs from the first by something. Now if we take the second alkane out, the second one is C2H6. okay, if we take the second alkane out, then subtract it from the first is CH4. You notice something definitely. Now you notice that they differ by something. Now C2 minus C is what? C. Then we have what? H. H6 minus H4 is what? H2. Is H2. Now take C3, subtract it from C2. C3 take C3, subtract it from C2. You have C3, then C2H4. You discover something again. C3 minus C2 will give us what? C. H6 minus H2 will give us what? To give us 2. So a group or a family of compound in which each member differs from the successive member, that is to say this one here differs, this one differs from the one that is following it, with a CH2 group or an atomic number. If you calculate the atomic number here, it will give us 12. This is carbon. Carbon is how many? 12. Plus hydrogen is how many? 1. 1 times 2 is how many? Is 2. 12 plus 2 is how many? This is 14. Are we getting it? Now when you see a family of elements in which each member differ from the successive member by atomic mass of 14, by atomic mass, not atomic number, rather by atomic mass of 14, or a CH2 group, that family of compound is called the what? The homologous series. It's called what? The homologous series. So the homologous series are families of compound in which every member differ from successive member by a CH2 group. Are we getting it? Now if you do, for instance, let's take this one first. Now C7 minus 6 will give us what? C. Then H14 minus H16. 14 minus 16 is how many? Is what? 2. So it's that every member differ from the successive one by CH2. Now C9 minus C8 will give us what? C. Then H20 minus H18 will give us what? 2. So every member differ from the one that follows it by what? A CH2 group. That family of compound is called what? Homologous series. So these are the homologous series for the alkanes from number 1 to 10. The first one is methane, the second one is ethane, third one is propane, fourth one is butane, fifth one is pentane, sixth hexane, 7 heptane, 8 octane, 9 nonane, and 10 decane. Now let's look at how to name the alkanes. Now the nomenclature of alkanes follow the general pattern. First of all, you call the prefix, then you call the parent, and the what? The suffix. Now the prefix most cases is usually a substituent. This prefix usually is what? A substituent. Now let's follow this following step to name alkanes. Now step 1 says name the longest continuous chain. Now how do we identify the longest continuous chain? The longest continuous chain is usually that chain that is what? Longest and what? And continuous. It's usually that chain that is longest and at the same time it's what? Continuous. That is the longest continuous chain. So in this compound, which is the longest continuous chain? Now the longest continuous chain, you agree with me that it is this chain here. This chain here is the longest continuous chain. Are you getting it? Is the longest. If you look at it, this has 1 carbon, 2 carbon, 3 and what? 4. Even this one too, you can also take it as the longest continuous, which is 1, 2, 3 and what? 4. Are we getting it? There are 2 long continuous chains. You can start your numbering from here. Here will be 1, here will be 2, here will be 3 and here will be 4. Then there's another chain that goes from 1, 2, 3, but this one is not as long as the one with 4. So in this case, we can have 2 longest continuous chain here. You can even have more than 2, but the one that will favor your substituent is the one that you usually will take. So the first thing is to name the longest continuous chain. Now the second one, number the longest continuous chain. Now the numbering is in such a way, if we take this as our longest continuous chain, okay, let's take this as our longest continuous chain. If we take this as our longest continuous chain, now where will the numbering start? Please take note of this. The numbering starts from the side. Numbering must start from the side where you get to the first substituent easily. From the side where you get to the first substituent. Now, if we number this way, this is 1, this is 2, this is 3, and this is what? 4. We got to the first substituent at carbon number what? 2. Now, how about if we number from this way? You can number from every side. So this becomes 1, 2, 3, and what? 4. Now you discover the one that is with white pen, that you got to the first substituent at carbon number 2, while from this side you got to the first substituent at carbon number what? 3. Hence your numbering should be from the side that will get to the first substituent easily, and that is the one with the white, because that one got to this first substituent at carbon number 2. Now the next thing is locate and name the substituent. So our numbering said this is 1, this is 2, this is 3, and this is 4. This is a substituent. Now the substituent is a methyl substituent. Is what? Methyl. Methyl groups are formed, or the alkyl group, they are formed when alkane loses 1 hydrogen. Okay, when alkane loses 1 hydrogen, alkyl are formed. Now if you go back to our previous slide on the general formula, you have CH4. That is the formula for what? For the alkane, the first alkane, CH4. But when CH4 loses 1 hydrogen, it becomes what? CH3. And CH3, instead of you calling it the normal methane, you are not going to call it what? Methyl, as a substituent. Are you getting it now? So this substituent here is a methyl substituent. So we are going to name the substituent. At what position is the substituent? The substituent is at position number 2. So this becomes 2, stating the position of the substituent, methyl, 2-methyl. Then the next step is combine the longest continuous chain and the substituent into the name. So this is 1, 2, 3, 4. We already said that this is a substituent and is a methyl what? Substituent, which we said is 2-methyl. So this is 2-methyl. Now the longest continuous chain has how many carbons? It has 4 carbons. When it has 4 carbons in our homologous series, when n is equals to 4, what is the name? The name is butane. So in order for you to have a head forward for this particular course, you must name this particular word substituent here, or this particular homologous series, the group. You must be able to identify them and also identify their names. Okay, so that compound is butane. Are we getting it now? So that compound is butane. So the name of this compound is 2-methyl butane. 2-methyl butane. So let's follow this pattern to name subsequent compounds. Now you are given the following compound to name. Said name the following compound. If there are more than 1 substituent in a compound, how do you name it? First of all, you have to indicate the number and the positions of the substituent. Let's identify our longest continuous chain. Now you agree with me that the longest continuous chain is this straight chain here. This is our longest continuous chain. Now let's name our longest continuous chain. From either side, when you name the longest continuous chain, you get the same numbering. This is what? 1, this is 2, this is 3, this is 4, and this is what? 5. Why from this side is 1, 2, 3, 4, and what? And 5. Okay, so from either side you are going to get the name of the same word compound. So let's erase the one under. If we erase the one under, the name of this compound becomes, now there are two substituents there, so you use the prefix what? Di. If there are two substituents, you use the prefix what? Di to represent them. If there are 3, you use the prefix what? Tri. If there are 4, you use the prefix what? Tetra. And if there are 5, you use the prefix what? 4, you use the prefix what? Penta rather for 5, and heza for 6. Okay, so the name of this compound would be, now indicate the position of the substituent. You have 2, the other substituent is at position what? 4. Then you now say 2, 4 dimethyl, because there are 2 methyl group there, so it becomes dimethyl. The longest continuous chain has 5 what? 5 carbons, and when it has 5 carbons, what do you call it? Pentane. So that's the name of this compound, 2,4-dimethyl pentane. Now the same way you are going to do for this case. If you number from here, first of all, what is the longest continuous? This is the longest continuous. Now the longest continuous chain is not usually a straight chain. You may need to take a bend in order to ascertain that. Okay, so our numbering will still be from either of the side. We can decide to take it from here. This is 1, this is 2, this is 3, this is 4, and this is what? 5. So the name of this compound is 3, 3. Why is it 3, 3? Because at carbon number 3 you have the two substituents. One is up and the other one is down. So this becomes 3, 3. Then what? Dimethyl. Tell you that there are 2 methyl substituents, still what? Pentane. So it's that they are the same compounds but different position of the substituents. We are going to look at that later. So this is 3, 3 dimethyl pentane, and this is 2,4-dimethyl pentane. Okay, now let's look at other compounds. You have, if 2 or more substituents are present, their names are alphabetized and added to the name of the parent alkane as one word. So this case now, what is longest continuous? At least everybody agrees with me that this is our longest continuous chain. Okay, this is the longest continuous. Now what will be the numbering? If we say this is number 1, now this will be what? Number 2, and this will be number 3, this will be number 4, this number 5, this number 6, this number 7, and this is what? Number 8. Now if you come from this side, what will be our number? If you come from this side, it becomes 1, what? 2, 3, 4. Now you discover numbering from this side. You got to the first substituent at carbon number what? 4, and the rule says that you must get to the first substituent, the one, or take the one that gets to the first substituent first. From this way we got to the first substituent at carbon 3. From this way we got to the first substituent at carbon what? 4. Hence this numbering will not work for this particular compound. Okay, now where are the substituents present? We have 2 substituents. One is this substituent. Let's say the substituents are in blue, and this is another substituent. So we have basically 2 substituents. Okay, now the 2 substituents, what will be their name? The first one is CH3, so we call it a methyl substituent. So we keep this one here, methyl substituent, methyl substituent. Now the next one is CH2CH3, and that is an ethyl substituent. Okay, that is ethyl. So we have 2 substituents, methyl and what? Ethyl. Now you name the substituent in alphabetical order between E and M. Which one comes first? E comes before M, and since E comes before M, you ought to name E first before M. Are we getting it now? So you have to name the ethyl group first before what? M. And ethyl is gotten from ethane. You know ethane is C2H what? 6. If you subtract one hydrogen, we said it will give you the alkyl group, which is what? C2 what? H5. Okay? So this is C2, which is C plus C, C2, then H2 plus H3 is H5, which is the ethyl. That is why it is called what? Ethyl. Of course, we know from ethyl before. So we have to name the ethyl group first. Are we getting it? That does not mean that the ethyl group will get the lowest number. You number normally to the first substituent or to the one that get to the first substituent easily. Then the naming now has to follow the word, the alphabetical order. So this becomes 5 what? Ethyl. Are we getting it? Then we have 3, because at position number 5 you have what? Ethyl. Then position number 3 you have what? Methyl. Then 3 methyl. And then the longest continuous chain is what? Octane. 5 ethyl, 3 methyl, octane. And that is the name of that compound. This is supposed to be like this: 5 ethyl, 3 methyl, octane, because octane is the longest continuous chain. So that's how to name this compound. Now let's go to the next one. Now, if 2 or more substituents are present, their names are alphabetized and added to the name of the parent alkane, again as one word. Now this is still the same thing. Now where are we going to start from in this case? This is 1, 2. First of all, let's identify our longest continuous. Now our longest continuous chain, of course, is this straight chain. Now it must be a straight chain, but in these cases we've been taking, is usually the word, the straight chain. These are our longest continuous. Are we getting it now? Now here are our substituents. We have this as one substituent. Okay, anything that is not part of the longest continuous chain is what? A substituent. So what will be the name of this compound? First of all, let's number. Now from what side are we going to number from? If we number from here, this is 1, 2, 3. Now if you number from here, this is 1, 2, 3. 1, 2, 3. But then we have to now make choices of our place of numbering, because from whatever direction we number from, we get the first substituent word first easily. Are we getting it now? So, or the same, at the same position. So we will number from the substituent that has the smallest numbers in the alphabetical order. Now of course everybody agrees that this is ethyl substituent, okay, and this is what? Methyl substituent. So we have ethyl substituents and methyl substituent. So between E and M, which one comes first? Is E. So we number from the side that gets to E first, okay, and this will become 1, 2, 3, 4. Then we have 5, 6, and what? 7. And then the name of this compound will be 3. Then ethyl, talking about the ethyl group now. Then we have what? 5 methyl. Then what? This is 1, 2, 3, 4, 5, 6, 7. Heptane. For 7 is heptane. So the name of this compound is 3 ethyl, 5 methyl, heptane. Let's name another group. Now, assuming you are given this, how would you name? First of all, let's identify our longest continuous. Our longest continuous is this, okay? Let's take it. This is the longest and it is continuous. So that's our longest continuous chain, okay? Now, where is our numbering from? Our numbering is from here. This is 1, this is 2, and this is 3. Now this is 4, this is 5, this is 6, and this is 7. Now we may see number from here. This is 1, 2. Okay, let me just number it. This will be what? 1. Here is what? 2. Here is what? 3. Now you discover that we got to the first substituent at carbon number 3 and 3. But then this one has 2 substituents here. Are we getting it? And because it has 2 substituents, we must at all time take this one first, because it has 2 substituents at 1 carbon, and that carbon is the closest what? Carbon. Hence we take this one first, okay? Now if we want to name this compound, so we can erase this, what will be the name? The name will become the name will become, now we have two substituents. Of course, we know that this is a substituent, which is what? Ethyl. And this is another substituent. This is what? Methyl. This is methyl substituent. And this is methyl substituent. Okay, so we have two methyl substituents there. So the name of this compound, we have, first of all, now another thing that we must take into cognizance is, if we're having di, it means the di will come before what? Ethyl. Are we getting it? It means the di will come before the word ethyl. Do we understand that? It means the di, because D comes before E in the alphabetical order. Hence, we are to what? To name the one that starts with di. And ethyl, there are two ethyl there. So the two ethyl will serve as what? Di-ethyl. I mean, there are two methyl rather. The two methyl will serve as what? Dimethyl. So the name of this compound will be 3, then we have what? 5. And this becomes dimethyl, because D comes before E. Then what? Position number 3, you have 3 ethyl, and the longest continuous chain is what? Heptane. So that is the name of this compound. 3,5-dimethyl 3-ethyl what? Heptane. That is the name of this compound. So that is basically that for that compound. Let's name another compound. Now, what if you have something like this? How do you name it? First of all, let's identify our longest continuous. The longest continuous is usually this straight chain, okay? You have it as 1, 2, 3, 4, 5, and what? 6. Why, if you number from this way, you have the first substituent at what? 2. This is 1, 2, 3, 4, 5, 6. So which numbering are we going to take? Now we take the numbering that in such a way that if you add them together, they will give us the smallest number easily. Now at carbon number 3, you have two substituents, so we can say 3 plus what? 3, because there are two substituents there, plus the next one is carbon number 5. So this becomes 3 plus 3 plus 5 is how many? 3 plus 3 is 6, plus 5 is 11. Now let's take the numbering from this side. At position number 2, you have a substituent, so you have 2, plus at position number 4 you have two substituents, so this becomes what? 4 plus 4. Are we getting it now? So 2 plus 4 plus 4, 4 plus 4 is how many? 8, plus 2 is how many? 10. So you see that from this side you got to the when you sum all the substituent number together, it gave you a lesser number. This is 3 plus 3 plus 5. 3 plus 3 plus 5 is 11, and 2 plus 4 plus 4 gave us what? 10. So our numbering will be from the side that when you sum all together, it gave the least number possible, and that position is this particular group here, this numbering from under. Are we getting it now? So the name of this compound now becomes, now position number 2 you have a substituent, so this becomes 2. Position number 4 you have another substituent, so this becomes 2, 4, 4. How many methyl groups are there? You have 1, there are 3 methyl group, 2, and what? And 3. So you call them trimethyl, and then the longest continuous chain is 6, which is what? Hexane. So the name of this compound is 2,4,4-trimethyl-hexane. Now, how about you have the compound like this? Let's assume you had it as CH3, then let's say C, then CH3, here is CH3, then you have CH2, CH, and then here there's a substituent again, CH3, and finally you have CH3. How do you name a compound like this? Now, of course, we know that the longest continuous chain is this chain in this case, okay? This is the longest continuous, okay? Now, I haven't know the longest continuous. Where are we going to number from? Now, if we number from here, this becomes 1, 2, 3, 4, and what? 5, okay? So this becomes 2, 2, Why is it 2 2? If you add all of them together, this one will give you, if you number from this side, this one will give you 2 plus 2 plus what? 4. Why, if you come from this side, this becomes 1 2 3 4, okay, which will be 2 plus 4 plus 4. Which one has the smallest number? This 2 plus 2 is how many? 4 plus 4 is 8. Why this one is 4 plus 4, 8 plus 2 is what? 10. So you take this numbering that goes this way. So the name of this compound becomes 2, 2, 4, then trimethyl pentane. And that is the name of that compound. Trimethyl pentane. That is the name of that compound. Now let's proceed. How about you are given something like this? How do you name it? How do you name it? Now you number from the side that will get to the first substituent easily. Are we getting it now? That is the approach. Number from the side that will get to the first substituent easily. Now which side are we going to number from in this case? Now the first substituent, you have substituent at carbon 2 here. If you number from this side, you have substituent at carbon 3 here. If you number from this side, are we getting it now? But this one now, if you take this one, this become 1 2 3 4 5 about 6. Why from this side becomes 1 2 3 4 5 6. Now add the positions of the substituents from both sides together and see the one that gives us the smallest number. Now this is 3 3. It means carbon 3 and carbon what? 3. There is what? Chlorine and bromine. So you take it as 3 plus what? 3 plus. Now the other one is at position 2, position 5 from this side. So this is 5. 3 plus 3 plus 5 is how many? Is 11. Now our number from this side will be what? 2 plus, now this position here is 4. So 2 plus 4 plus 4. 2 plus 4 plus 4 will give us, I think, 10. So our numbering will be from the under, okay? Our numbering will be from the under. So this will become, at what position do we have the substituent? Position 2, 4, position 2 and 4 rather. And we have bromo group, which is bromine for bromo, and then we have chloro group, which is chlorine for chloro. Are we getting it now? Then we have the methyl group. We have 3 substituents. Now which of them are we going to name in alphabetical order? Bromo comes first before chloro, and then what? Methyl. So this become 4 bromo, 4 chloro, 4 bromo, 4 chloro, then what? 2 methyl, and the longest continuous chain of course is what? Hexane. 2 methyl hexane. So the name of this compound is 4 bromo, 4 chloro, 2 methyl hexane. That's the name of that compound. Okay. Now let's look at another one. You have this compound given to you, and you are asked what is the name of this compound. Now first of all, we need to understand something which we are going to treat later. You have the CH3 here facing upward, and you have the CH3 here facing downward. Then you have hydrogens here and hydrogens here. Now whenever you have something like this, such a way that the CH3s are two the same, and then we have hydrogen, you use isomerism to start the naming. Okay, so this one is facing up, while this one is what? Facing down. So you say this is trans, because the two hydrogens are not the same side. One is facing up and the other one is what? Facing down. So you say this is trans, and then this compound, your numbering starts from any of the substituents, okay, to the next substituent. So this is 1, this is substituent CH3, and this is what? 2, this is 3, this is 4, this is 5, and this is what? 6. It's a cyclohexane ring because it has 6 compounds in cyclic. So you say this is trans 1, then 4, to tell you that there's a substituent at position 1, there's another substituent at position 4. And what are those substituents? They are what? Dimethyl substituents, because 2 methyl group, dimethyl cyclohexane. Okay, so that is the name of that compound, trans 1,4 dimethyl cyclohexane. Let's see if there's another compound here to name. Now you are given this compound and you are asked to name it. Where do we start our numbering from? Now we start our numbering from the side that will get to the first substituent easily. Now this group here is CH2 group, okay? This group here. So we have CH2, CH3. Of course, we know that this is a this is an ethyl substituent, okay? This is ethyl substituent. Now this one has how many carbons? This is carbon 1, carbon 2, and carbon 3. It has 3 carbons. So you call it what? Propyl substituent, okay? Now the methyl substituent and the propyl substituents. Now between the E and P, which one comes first is E. So our numbering start from here, 1. Now you don't number to this side. You don't number anti-clockwise. You number to the side that will get to the first substituent, to the next substituent easily. If you number from this side, you have to get to the next substituent at position 1, this 2, 3, 4, and 5. Are you getting it now? So that numbering will not work, okay? Because the next substituent will be at position 5. So in this case, our numbering is taking this turn. So this is 1, 2, 3. Here becomes 4. Here is 5, and here is what? 6. Okay. So the name of this compound now will be what? What are the substituent? Ethyl substituents at position 1. So this is 1 ethyl. Okay. 1 ethyl. Then position number 3, you have propyl. So 3 propyl. 1 ethyl, 3 propyl. Now how many carbons has a ring? It's 6. So you call it cyclohexane. Okay, hexane has 6 because it's cyclic. You put it as what? Cyclohexane. That's the name of that compound. Now in this case, we have to number from the side that will give us the minimum numbering. So if we take this at carbon 1, here is carbon 1, here will be carbon 2, here will be what? Carbon 3. Here is carbon 4, 5, and what? 6. Now, whenever you have two substituents together, in such a way that the other substituents are just close by, you must start your numbering from those two substituents together. So these two are together. We'll start it, then go to the next substituent and to the next, and like that. So the name of this compound becomes, now first of all, you have methyl substituent here. This is methyl, okay? Then here is 1, 2 carbon. This is ethyl substituent, okay? And then this one is another 2 methyl substituent. So our numbering must start, our naming must start with the ethyl. So this becomes 2 ethyl. Are we getting it now? 2 ethyl. Then you have 1, 1 to tell you that at position 1 here there is a substituent and there's another substituent. 1, 1, 3. Position 3 here there's another substituent, methyl or trimethyl, to tell you that there are 3 methyl there, okay? 2 are at 1 and 1. That is why you have 1 and 1 here. Then the other one is at number 3. That is why you have 3 here. Trimethyl cyclohexane. I believe that this is an exam question, okay? So that is the name of this compound. 2 ethyl, 1, 1, 3 trimethyl cyclohexane. That is the name of that compound. Now let's look at the boiling points of alkanes. The boiling points of straight chain alkanes have a higher boiling point than their branch chain isomers. So if an alkane have the same number of carbon atom, the boiling point of the straight chain alkanes usually have a higher boiling point than that of the branch chain. So branch chain reduces boiling point while straight chain increases boiling point because it has more surface to contact with. Are we getting it now? So this one here, which is CH3, CH2, CH2, we have a higher boiling point, okay, than this one because they are the same compound but different arrangement. This is 1, 2, 3, 4 carbon. This is 1, 2, 3, 4 carbon. So because this one is straight, it will have a higher boiling point than this one that is branch. So this comparison between these two compounds, these have a lower, while these have a higher boiling point. Now let's look at these 3 compounds. Which of them do you think we have the highest? Now this is straight chain, so this one will have the highest boiling point. Now this one is a branching, but the branching is at just 1 carbon, so this one will have the second highest. And then finally this one has 2 branches. They are the same compound having 5 carbon. 1 2 3 4 5, 1 2 3 4 5, and then 1 2 3 4 5. This one is the second, this is the third, or the lowest. Okay, this is the lowest because it is more branched. So do we get it now? That branching reduces the boiling point of alkanes. Branching reduces the boiling point of alkanes. Are we getting it now? Straight chain alkanes usually have higher boiling point than their branching isomers. Okay, let's continue. Now, the melting point. The higher the branching, the higher the melting point. So compounds that are more branched have a higher melting point than the ones that are what? Straight, or the ones that are symmetrical. The ones that are not symmetrical, they have a higher melting point. So when you consider this compound, you see this compound is somehow symmetrical. It do not have a melting point as high as that of this. So this one have the highest melting point here, followed by this, even though both of them are branched at 2 positions. This is branch here, branch here, while this one is branched at the same word position. But then this have a highest melting point than this. So this has a higher melting point because the symmetry here make this not to have a higher melting point than this. Now, what makes it to be symmetrical? If you divide this into 2, you discover that this part is equal to, let's say we divide it into 2, discover that this part is equal to this part. Are we getting it now? So this one is the second highest in terms of melting point, and then this one is the what? Is the lowest in terms of melting point, because this one is just branch at one position. So this is for melting point. Okay, now how about if we consider the boiling point of this compound? The boiling point, which of them is the highest and which of them is the lowest? Now you agree with me that from this way like this one will be the highest, because we said branching reduces boiling point, while the one that is less branched have the highest boiling point. So this one has the highest boiling point, so at any position this one is also what? Second highest, and then this one is the what? Lowest for boiling point. So it's that the boiling point is the opposite of the what? Melting point. Okay, let's look at other examples. Now you are given this exam question: which of the following alkanes have the highest boiling point? Of course, without solving, you know that the correct answer, let's say this is A, this is B, this is C, and this is D. Which of the following alkanes have the highest boiling point? Of course, you know that this is the correct answer, because we said that the ones that are less branched are the ones that have the highest boiling point. Are we getting it? The ones that are less branched, that means straight chain alkanes have higher boiling point. Now, how about you are given, for instance, let's say C2H, or let me draw the structures. How about you are given something like this, okay, and then you are given another thing like this? Which of them do you think will have the highest boiling point and the highest melting point? Now, boiling points and melting points increases with increasing atomic weight. So the one with the highest atomic weight will have the highest boiling and melting point. Now, of course, between these two compounds, the one with the highest atomic weight, now this is 1 2 3 4 5, which is C5 according to the homologous series H what? 12. Why this is 1 2 3 4 5 6 7, this C7 H what? 16. Okay, now this is pentane and this is what? Heptane. Now when you look at these two compounds very well, pentane and heptane, you discover something tremendous here. Which of them do you think will have the highest molecular formula or the highest molecular weight? Of course it's heptane, because heptane has its longest chain. Are we getting it? If you calculate, this is 12 times 7 plus what? 1 times what? 16. Of course that will give us 12 times 7 is about 84. 84 plus 16 is about 100 gram per mole. Okay, why this one is 12 times 5 plus 12. 12 times 5 is how many? 60, plus 12 is how many? 72. So you see that the one with 100 gram has a higher boiling and melting point than the one with what 72 grams. So when you just look at them, the one with the longest chain usually have the highest what boiling point as compared to the one with what a smaller chain. So you may be given chains and you are asked which of the following have the highest melting and boiling point. The one with the longest chain usually have the highest melting and boiling points. Okay, now let's proceed. Let's talk about the method of preparation of alkanes. Now we have the first one here, alkanes or alkynes, which is hydrogenation of alkanes. That's the first method. Now there's something said alkanes or alkynes are reacted with hydrogen in the presence of nickel catalyst at 200 to 300 degrees Celsius to form alkanes. Other catalysts which can be used are platinum and what palladium. Now what are the formulas for alkanes? Alkanes are ROCH double bond CH2. This general formula. So when alkanes are hydrogenated, that is, reacted with hydrogen gas in the presence of nickel or platinum or palladium as a catalyst at a temperature of 200 to 300 degrees Celsius, alkanes are formed. So what will be the product of this reaction? R. Now something happens here. If this H breaks down, it gives you 2H. Now in this case, one of the H will come here and this other H will come here, and when they come here, what will happen? The double bond will break. Are we getting it? If the double bond break, it's going to form something like CH. Now we already have one H there, the other H joining, making it to be 2H, then CH. Now you already have one H here. If the other one H join, becomes what? CH3. So this is the name of this is the compound that will be formed, RCH2CH3. So for instance, if you have, let's say, something like this, they gave you something like this plus H2 gas, and you were asked, let's assume you are given something like this and you were asked what will be the product of this reaction. Now of course, if you want to break this down, it becomes CHC double bond C and then this, right? Now we said carbon must have a valency of how many? A valency of 4. So if you already have 2 double bond here, it means you add how many hydrogen? 2 hydrogens here. Okay, now this one, if you already have 3 bonds, which is 1 2 3, how many hydrogen do you need to add? You add one what? Hydrogen here. So in this case, you have H2 CH2 double bond CH and what? This. Now this thing, you can also write it plus what? This H2 means H and what? H. What happened? One of the H comes here and the other H comes here. Okay, so the product of the reaction will become, if this H comes here, how many H are we now going to be having here? 3. So this becomes CH3. Then you have, if this H come here, what are we going to have here? This becomes what? CH2. And then we know that this line here means what? CH3. So this becomes CH3. So when propene, this is propene, is hydrogenated in the presence of nickel, platinum or palladium at a temperature of 200 degrees Celsius to 300 degrees Celsius, the product form is what? Propane. Is what? Is propane. Now let's look at another example. Assuming you are giving, let's say in your exam you are giving CH3 CH double bond CH3 plus, let's say, H2. Now what do you think will be the product of this reaction? What do you think will be the product? Of course, we know that this H can break down to give you 2H. Now one of the H visit here and the other H visit here. Now why is it that they always visit these 2 carbons here, carbon A and B? It is because this is the site of reactivities of the alkene. Okay, when this H 2 sigma bonds, so you can say whenever 2 sigma bonds are added, one bond is broken. Okay, one bond is broken. Whenever at all 2 sigma bonds are added, one bond is broken. So when you add that, the product of this reaction becomes CH3, then CH2, CH2, and what? CH3. Because when this hydrogen adds here first, you have CH2, 1 plus the other hydrogen. Then this one adds also to give you CH2, and finally what? CH3. So this is one method for preparation of alkanes, hydrogenation of alkanes. When alkanes are hydrogenated, the product formed is alkanes. So if I give you, if pentane is hydrogenated, what will be the product form? The product form will be what? Pentane. Okay. If hexane is hydrogenated, the product form will be what? Hexane. Now, if cyclobenzene is hydrogenated, the product form will be what? If benzene is hydrogenated, if it is hydrogenated, the product form will be what? Cyclohexane. I believe there's a question on that there. We'll do it later. Now, the other one is reduction of alkyl halide. Reduction of alkyl halide with Nuncent hydrogen. Alkyl halide undergo reduction with Nuncent hydrogen to form alkanes. Now, this concept of Nuncent hydrogen, what does it mean? Now, of course, we know hydrogen is usually in the form of H2 paired together. Are we getting it? This form of hydrogen is not very reactive, okay? It's not very reactive, So another concept of freshly prepared hydrogen was what was postulated, and that is what is called Nuncent hydrogen, and it consists of individual atoms of the word hydrogen instead of pair. So you have H2 as your normal hydrogen, then H atom as what? Nuncent what? Hydrogen. Are we getting it now? H atom as Nuncent hydrogen. Okay. So when alkyl halide is alkyl group with halogens. Alkyl group is ROX. When alkanes loses hydrogen, forms alkyl. The alkyl group is represented with R. Then X means what? Halogen. And the halogen can be either chlorine, bromine, then iodine or fluorine. But fluorine is very what? Reactive. Hence, both of the reactions of fluorines are not studied. Okay. So when ROS, alkyl halide, react with Nuncent hydrogen. Now you see the way I'm going to write this hydrogen. I'm not writing it like H2. It reacts with two of the individual hydrogen atom. Alkanes are formed and what? Hydrogen halide. Now, what did you see in this reaction? This 2H means what? H and what? H in the same vein. This one does what? Comes here and then remove this X from here. This S paired with this other one to form what? HS. Now, one thing that you must know is, let's not go into that for now. So this gives us R. Then you have what? We've already written the product of that reaction. ROH plus what? HS. So for instance, if I give you, let's say CH3, CH2X. The X, let's use bromine. This is ethyl bromine, okay? Ethyl bromine, or you can call it bromoethane. Ethyl bromine or bromoethane. When it reacts with Nuncent hydrogen, what will be the product form? Now, of course, this will give us the two hydrogen breaks down. This one will substitute this. What will happen? This hydrogen react with this to form, first of all, HBr. So when this one adds to this, it forms CH3, then CH. Now, normally we have to hear if one of the hydrogen adds, what is it going to give to us? CH3. So this is ethane, okay? So when ethyl bromine reacts with Nuncent hydrogen, the product form is ethane and what? Hydrogen bromine, okay? So that is one of the methods for preparation of alkanes. One of the methods for preparation of alkanes. So it may be given in your exam, may be given something like this: bromine plus 2H. What will be the product? The product will be what? Just this, which is CH3, CH2, CH3. This is 1, 2, or let's say, the product of this reaction will be something like this. Why? Because this is what? This group here means bromine group. So if this one is removed, you form just a straight chain. Maybe I should write it out in the normal. This thing is the same thing that we wrote there. This representation is better for your understanding. So That is one of the methods. Now you may be asked, which of the following methods is not a method for preparation of alkanes? They will give you, first of all, hydrogenation of alkenes or alkynes. Then secondly, hydrogenation of reduction of alkyl halide. This is a method. Then you may be given other methods that are not what methods. Okay. Now there's something that we didn't touch here. This one said alkanes or alkynes, or maybe we are going to do it in later. Let's just do it now. This one says alkanes or alkynes. So how do we achieve for now? How do we achieve for alkynes? Now alkynes have triple bond, okay, and then H. When you react there with hydrogen gas in the presence of nickel, okay, at a temperature of 200 to 300 degrees Celsius, what will be the product form? Now first of all, they will give you alkene. So because when these two add to this place, what will happen? If these two add to this place, one of the bond will be what? Will be broken. So you have R C double bond C and what? H. Are we getting it now? One of the bond will be broken. Now if the bond is broken, you now have alkene. So this alkene now cannot be further what? Hydrogenated to give us, if this alkene is hydrogenated, it means this one will come here, while this other one will come here, and this gives us R C. Then here will not be, here is supposed to be H because the H added here, and here is supposed to be what? Another H, which is H2 here. Okay, let me write it where this gives us H2 here. So when this other two adds now, here will now be what? R C. This H adds to this CH here, becomes what? CH2. Then here it gives us what? CH3. We've already learned the one from alkene to alkane. So first of all, to hydrogenate alkyne to alkane, you first of all go from alkyne to alkene, then from alkene to what? Alkene. Are you getting it now? Or you can just directly go from alkyne to alkene by adding what? 2H2. It's telling you that there are 4 hydrogens here. When these 4 hydrogens enter here, we say 2 hydrogen breaks a double bond. So 4 hydrogen will breaks how many bonds here? It brings 2 bonds here. Are we getting it now? So this gives us directly ROCH2 and what? CH3. Okay, this is the alkane. So when alkynes are hydrogenated, the product is also what? Alkane. Now back to our hydrogen bromide. I think we are done with the reduction of alkyl halide. So that is basically all that we'll be doing for this particular lecture. Or let's take one more. The next one is decarboxylation of carboxylic acid. When sodium salt of carboxylic acid is heated strongly with sodium lime, sodium salt of carboxylic acid is something like this. Let's say you have CH3 COONA is heated strongly with when this is heated strongly with sodium hydroxide, when it is heated strongly with sodium hydroxide and sodium carbonate, so we have sodium hydroxide then plus what? Heat. The product of the reaction is what? An alkane, in such a way that now I said a molecule of carbon dioxide is split off as carbonate and alkane is formed. The alkane formed is 1 carbon less than the original. So if this carboxylic acid is CH3C, it means it has 2 carbons here. Now if it is 1 less than, it means that this group here will low, it will go off, then hydrogen will be added here. Are we getting it now? If hydrogen is added here, what are we going to form? We'll form what? CH4 plus. Now this group here, you have now this group plus this group. You know this hydrogen was the one that added here, okay, to CH3 that gave us CH4. Now these two groups now will now combine together as sodium triazocarbonate. So that sodium thiazocarbonate now is sodium 2, because you have 2 sodium, then C, then how many O are there? 1, 2, then what? 3. O3. So this will be what is formed. Now the general form of this equation is ROCOO Na plus sodium hydroxide in the presence of what? Heat. Now what will happen here? First of all, we say this hydrogen will come here attached to this one to form what? ROH, isn't it? This is an alkane. Then plus sodium to CO3. Okay, so that is what is practicable in this one. Decarboxylation of what? Carboxylic acid. When sodium salt of carboxylic acid is heated strongly with soda lime, which is a combination of sodium hydroxide and calcium hydroxide, a molecule of carbon dioxide is split off as carbonate and alkane is formed. The alkane formed is 1 carbon less than the original. So if I give you something like this, let's say CH3 CO not COO now, CH3, let's go a little bit longer, then CH2 and then COO Na plus sodium hydroxide, then heat. What will be the product? The product will be one carbon less. That means this carbon will leave. Then you add hydrogen here to make it what? 3. So this becomes CH3, CH2, and what? CH3. And this is propane. So when sodium butanoate, this sodium butanoate as name, when sodium butanoate is heated with sodium hydroxide, the product formed is propane, because it will form an alkane with 1 carbon less than the original alkane. So that is that for that particular question, for that particular something rather. Decarboxylation of carboxylic acid. To decarboxylate means to remove the carboxylic group. Are we getting it? Just get the imagination. To remove the carboxylic group. Decarboxylate, like deactivate, to remove activation. Decarboxylate means to remove the carboxylic group. So in this case now, the carboxylic group is being removed. This is the carboxylic group here. It's completely removed. Then hydrogen, 1 hydrogen is just added. Are we getting it? To form what? An alkane. So that is that. Now you may be given now the next one is hydrolysis of Grignard reagents. Alkyl magnesium halides are called the Grignard reagents. They are obtained by treating alkyl halide with magnesium in anhydrous ether. This on treatment with water gives alkane. Now the Grignard reagent, they were synthesized by Victor Grignard in the year 1912, of which he actually won a Nobel Prize for. The Grignard reagent. Now the general formula, I don't want to bother you about how they are prepared. General formula of Grignard reagent is MgX, where ROMGS, where RO is an alkyl group, then you have magnesium, and then X is halogen. So they are called alkyl magnesium halide. Now the Grignard reagent, they form important reagent for synthesis of alcohols in organic reactions. But in this case, we are going to look at how Grignard reagents are going to form alkanes. Now I said by treatment of Grignard reagent with water, alkanes are formed. So let's say you have R, then MgX plus H2O. This water can split to form H and OH, right? Then what happens? Now, if this H comes here, it forms alkane. So you have RO what? H. Then this Mg and this OH, you can write it as what? Mg, then bracket what? OH, and then what? X. This OH entered here, MgOH what S, why this H came here. So that is how Grignard reagents are used for preparation of alkane. So for instance, if I give you, let's say, this compound, let's say alkyl methyl magnesium bromide, which is CH3, then Mg Br. This methyl magnesium bromide is a Grignard reagent. If I react it with water, what will be the product? The product will be in such a way that this water splits to give us H and OH. One of the H attached to CH3 to give us what? CH4, plus then we have Mg. Then this OH we now combine with the other compound MgOH are what? Br. So let's take another example. If you have CH3 CH2 Br MgBr rather MgBr plus H2O, and you enhance, what will this form? Of course, you know that first of all this H splits down to give us H2O, splits down to give us H and OH. One of the H comes here to give us what? CH3 CH3, because if that H comes here, if it comes here, it adds to this one to give us CH3, then plus we are now going to form what? Mg, then OH, and then what? Br. So practically that is how to profile solution to that question. Okay, that's how to profile solution. So if I give you CH3 CH2 and then CH2 MgBr plus H2O, what do you think will be the product of the reaction? The product will be in such a way that you have H and what? OH. This H comes here. When it comes here, it gives us what? CH3 CH2 CH3. That is basically all for this case. Now let's look at the next one. The next one is Wood's reaction. Higher alkanes are produced by heating alkyl halide with sodium metal in dry ether solution. Two molecules of alkyl halide loses the hydrogen atom as NAS. The net result is the joining of two alkyl group to yield the symmetrical what? Alkane. So you must, in this reaction, you must have two what? Two alkyl halide with sodium metal. So this, you may have it as sodium in dry ether. Ether is ROO. Okay, this is the general formula for the ether. Now what will be the product form? It will form a symmetrical alkane. Are we getting it now? To form a symmetrical alkane, then sodium what? X. Depends on the halogen that is given. Let's take for example, if you have 2 CH3 bromine, react it with sodium in ether, what will be the product form? To form a symmetrical alkane in such a way, you saw this case that the arrow was repeated 2 times, right? Same thing is applicable here. The arrow will be repeated what? Twice. Now in this case, what is our arrow group? Is the alkyl group here. Are we getting it? That is our arrow group. So this becomes CH3, then what? CH3 plus, now sodium and bromine will come together to give us what? Sodium bromide. For now, I'm not bothering if the reaction is balanced or not, but we just follow this case like this. Okay, so that is basically the Wood's reaction. The Wood's reaction is mostly used for the synthesis of symmetrical what? Alkanes. Let's take another example. Assuming you have CH3 CH2 and then Br, you pass it through sodium in dry ether. The ether must be dried. What will be the product? You have to repeat this our alkyl group twice again. So this gives us CH3 CH2 CH2 and what? CH3. Are you getting it now? Twice of the initial group here. Are we getting it now? So that is one of the methods for preparation of alkanes, the Wood's reaction. Now the next one is, I think this also Wood's reaction, the Cobb synthesis. Now when a concentrated solution of sodium salt of carboxylic acid is electrolyzed, alkanes are formed. When a concentrated solution of sodium salt of carboxylic acid is electrolyzed, alkanes are formed. For instance, let's say you are giving, or let's write the general formula. The general form is 2ROCOO Na then plus 2H2O. Now this one will form RO plus 2CO2 at the anode, and then it will form 2NaOH plus H2 at the cathode. Okay, but then this mechanism is not really important for your level. Okay, it's not really important for your level, so we may want to leave it. Now let's say you are given something like this, 2CH3 COONA plus 2H2O. What will be the product? The product will be CH3 plus 2CO2 at the anode plus what? 2N. This is what is usually formed at the cathode. It's called the cold electrolysis. Okay, when it is electrolyzed. What is electrolysis? Is the chemical decomposition of a compound when a current is passed through it. So this compound will decompose. It's more like decarboxylation reaction. Okay, then this CH3 and another CH3, because two of them are present here, they will combine together to form this. The mechanism is not what is important to your level now. So this is basically where we are going to stop this lecture for now. Now in our next lecture, we are going to look at the chemical properties of alkanes, some of the reactions that alkane can undergo. Thank you for your time.